Initially, I was going to cover cannons in one video. Then it became 2. Then it became 3, and here we are. Hopefully, this is the 4th and final. When I first started researching cannons, I only skimmed the instructions on how to aim them, as I found them to be rather arcane. But after receiving requests about it, I couldn't quite shake the itch. So I decided to dig into the period manuals, both the English and the French, and it doesn't seem quite as complicated as I made it out to be. Still, I don't regret not including it in one of the previous videos, because this is a subject worthy of its own video, and I think it requires previous knowledge about the basic operations of the cannon and how it was used tactically, because we're going to get into some more advanced parts of the gun, and maybe even a bit of physics. Hooray for science, or well, magic. In the 17th century, some people considered mathematics a form of magic. Just look at some of these tables a gunner had to know inside out. Anyway, how to aim a cannon. First of all, we need to discuss ranges. I mentioned in Throwing a Biscuit that sea battles seldom occurred outside of speaking distance, that is, speaking distance with a trumpet. It would be more correct to say that most sea battles occurred within point blank. We usually interpret point blank as meaning in your face. The technical meaning actually stems from the age of sail, and specifically artillery. It basically means the range at which a firearm shoots straight. Beyond point blank, the bullet will lose its initial burst of energy and start dropping. If you're aiming at a target beyond point blank, you'll have to raise your aim above the target to compensate for the bullet drop. More on that later. This means that different firearms have different ranges, mostly depending on their construction and powder charge. I've compiled the ranges of the most common artillery at sea. It corresponds to my simplified table of artillery, provided in one of the previous episodes, Throwing a Biscuit. Cannons had 3 types of ranges: shoots point blank, SPB, the range at which the gun shoots straight; point blank range, PBR, the maximum range when the gun is elevated point blank, that is, you haven't elevated the barrel above point blank. Lastly, maximum range, which should be self-explanatory. The farthest distance a cannon might fire when elevated at 45 degrees. I won't read out all of the distances, you can check it out yourself, and also convert the measurement to whichever one you fancy. Manuals of the time recommended that you never fought an engagement outside of musket shot. The effective range of a musket was between 100 to 200 yards, 90 to 180 meters. This is well within point blank for most cannons and would still allow you to use additional weapon systems. Muskets, of course, and swivel guns. In my video on how to operate a cannon, I gave a brief overview on the most important parts of the cannon. To freshen up your mind, I'll do a quick rundown on the parts most important for this video, and then I'll cover some additional parts. The most important part of the gun is the barrel, or piece. The mouth is called the muzzle, and the back part the breech. The interior of the piece is called the bore, and the back part of the bore, where the powder and shot are loaded, is called the chamber. The absolute front of the gun isn't flat, but reinforced by the muzzle ring. You'll find a similar ring at the breech, called the base ring. This is the highest point of the gun. When aiming any type of firearm, you want to ensure that the barrel, which shoots out the projectile, is aimed right at your target. You can grab a pencil and pretend it's a gun barrel. Stick it against your finger. Now you're certain that the bullet would hit. But if you lead the pencil away, wiggle it up and down, are you still certain? Those of you who have played first-person shooters, or maybe even fired a gun yourself in real life, most of my audience is American, you'll know that you have to look down the barrel to ensure that it's properly aligned. Optimally, firearms are furnished with a rear sight and a front sight, which you need to align on your target to ensure that the entire barrel is pointed at it. Here lies the issue. A cannon barrel isn't straight. It's tapered, narrow at the muzzle, wide at the breech. When aiming, you've placed your eye behind the base ring, which stands higher than the muzzle ring. So if the gun is elevated horizontally based on the base ring, you're going to miss your mark. To aim the cannon correctly point blank, you'll need to find the difference in height between the base ring and muzzle ring, and compensate for it accordingly. This difference is called the dispart. There existed multiple ways of finding the dispart. I think I've encountered 3 or 4 in period manuals, and they claim to know additional methods. The simplest ones are the ones I call the iron method and the straw method. With the iron method, you take your priming iron and stick it into the touch hole of the gun until it touches the metal at the bottom of the chamber. Then you mark the iron where it reaches the highest point of the base ring. I'm not sure if they had chalks or made little cuts with a knife. Then you move the iron to the muzzle, press it against the bottom of it, and make a mark where it reaches the highest point of the muzzle ring. The distance between these two marks is the dispart, the difference in height between the base ring and muzzle ring. You can then take a little stick or straw or piece of wood and cut it into the size of the dispart. The straw method was basically doing the same as the iron method, but instead of an iron you used a stick or straw, and instead of marking it you broke it off until it got down to the height of the dispart. The dispart is then placed on the muzzle ring using wax, pitch or clay. Some cannons appear to have come with a ready-made sight piece. I've only ever seen one depiction of it from a French manual. It looks like a headless body with 2 crescents connected with a bar. You placed it on the muzzle ring and then tied together the threads at the points of the lower crescent, securing it to the muzzle. The sight was either made from wood or copper. The benefit of the sight piece was that you had it ready-made, and hopefully it was made with enough caution to be reliable. The benefit of a dispart stick was that you could make it longer or shorter to compensate for the drawbacks of your gun, or if you needed to aim beyond point blank. The drawbacks of the stick should be obvious. It took some time to make, was harder to attach correctly, it could fall off, and it's a smaller sight to aim with compared to the sight piece. But I don't think you made the stick in the heat of combat, unless desperate. You probably had it ready-made, unless if the gun shot really poorly and you needed to adjust it. And then you might just aim based on instinct. Anyway, with the dispart ready, you can align the dispart and base ring onto your target. To do this, you tell a matros to lift the piece with a handspike, while you aim down the barrel and adjust the coins which secure the piece. When the gun is aimed correctly, tell the matros to stop. Of course, a lot of gunners probably didn't need a dispart sight. They might have been so familiar with their piece that they could aim without it. You might also lack the time to make a dispart. In this case, one manual recommended that you aimed along the side of the cannon. Let's say you want to fire at a target beyond point blank. You would most likely never fire broadsides beyond point blank, because so many factors would decrease the likelihood of hitting a smaller target as an enemy ship at that distance, unless if you were bombarding a land target and precision wasn't paramount. However, firing at an enemy ship beyond point blank could be reliably done with chase guns, the long pieces mounted in the front and back of the ship. Beyond point blank, the gunner has to compensate for bullet drop by elevating the piece correctly. To find the right elevation, gunners used a tool called the gunner's quadrant. Invented in the 1540s, they came in a lot of shapes and sizes, but the basic sort consisted of a staff, a grip, a dial, and a plumb bob, also called a pointer. The dial is marked with angles of elevation between 0 to 45. Why 45? They did some experiments and discovered that a cannon elevated at 45 degrees would fire 10 times farther than it would when elevated at 0, point blank. So the quadrant was marked into 10 equal parts. The range of the gun would therefore increase by 1/10 each time the barrel was elevated to the next mark on the quadrant. I've also seen period quadrants where the 6th marker is at 45 degrees, and manuals stating that elevations at the 6th marker is the max range of the cannon. I find it easier to explain the 10th marker quadrant, and the basic theory remains the same whether you have 6 marks or 10 marks. An elevation of 45 degrees will always shoot the max range. The problem is that no gun is the same. Each is loaded with a different powder charge and bullet. So the gunner had to calculate by how much the range increased by every 1/10 on the quadrant for his individual piece. Gunnery manuals were often furnished with lengthy tables containing such information. For example, a Spanish mathematician in the 1590s experimented with a culverin firing a 20-pound iron ball. At point blank, it fired 200 paces. At a 45-degree elevation, it fired 2,000 paces. By elevating it to the first mark on the quadrant, it could fire an additional 180 paces beyond point blank. Why just 180 and not 200? Bullet drop, I presume. The results weren't always consistent with the theory. So, let's take the previous example with the Spanish culverin. It needs to hit a target 560 paces away. How does the gunner aim with the quadrant? Firstly, he puts the staff of the quadrant into the mouth of the gun. He brings his sights onto the target. Then, the matrosses elevate the piece until the plumb bob on the quadrant points at the second mark on the dial. Remember, for every mark on the dial, the range of a piece increases by 1/10 of its maximum range. So to calculate the current range of the cannon, we can use this formula. Max range divided by 10 minus max range divided by 100 times x, x being the current mark the quadrant is elevated at, from 0 to 10, and finally, add the point blank range. The max range of the culverin was 2000 yards. Divided by 10, we get 200. Minus 20, max range divided by 100, we get 180. We elevated a piece to the second mark on the quadrant, and 2 times 180 is 360. Add that onto the point blank range of 200, and we get 560 yards, which was the distance to our target. This is how you aim a cannon, beyond point blank. When the gun is aligned on your target, you are ready to prime and give fire. Now, will you actually hit? That's another question entire. Ships are constantly moving, both from trying to outmaneuver each other and from the ocean rising and receding. The gunner has to rely on a good helmsman to keep the ship steady and aligned with the enemy. He has to time the firing with the movements of the ship, the enemy's ship, and the sea. It was better to fire low than high. If you fired too high, the bullet might miss altogether, but if you fired low, it could strike the enemy in the hull or below the waterline. If the waves were high, it was best to fire when the enemy began to rise. But even then, there were countless factors that affected your accuracy. In his manual, The Sea Gunner, John Seller provided a rather motivating excerpt. Besides these aforementioned, there are many other accidental alterations which may happen, especially at sea. Sometimes, by reason of the wind, the rarity or condensation of the air, the heating or cooling of the piece, the different charging by ramming the powder fast or loose, by close or loose lying of the bullet, by the unequal recoil of the piece, or by reason of the ship being upon attack, and the gun standing on the wind, ward or lee side of the ship, or by the uneven lying of the piece in the carriage. With diverse such like accidents, whereof no certain rules can be prescribed to reduce those uncertain differences to any certain proportions. But all these by practice, experience, and a good judgment are to be performed. TLDR, get out there and shoot some cannons. Huge thanks to my generous channel members and Patreon supporters. In particular, Cole Freer, Max Dweck, 1660, Michaela Jans, Daniel Stryker, Sea Dog, Randall DeVere, Old Man Said, and Krillov. If you'd like to interact with me or fellow Pirate History enjoyers, please check out the link to our Discord server in the video description. Hope to see you there. Cheers!